Good morning, all of you. First of all, I would like to thank the organizers for organizing this meeting. I'm Abdul Qadir, and I'm working in the department. I'm a PhD student in the Department of Physics, Aligarh Muslim University. Today, I will present my ongoing work on the directed Abelian sandpile on a cylinder. So, as we know in the nature, we have lots of many systems which shows intermittent burst and scale free behavior. So, and such systems naturally evolve toward the critical states. So, in 1987, the Beck-Tang and Weisenfeld proposed the idea of self-organized criticality, in which this explains the mechanism in which the system dynamical systems self-tune to a critical states. In the proposed idea of this sandpile model, it was like a formation of sand on a flat surface, and after when we used to put the grains at each time step, after some time it will form some shape, and after then it used to topple and reshape itself. So this suggests that the system evolves into a self-invariance state, and it shows the criticality emerges naturally. These are the two papers by the Beck-Tang and Weisenfeld. In 1989, the Professor Dhar and Ramaswamy they solved a model and proposed the first solved model on self-organized critical phenomena, in which they put a preferred direction for the propagation of avalanche activity. So in the directed Abelian sandpile model, I'm looking for the forbidden states rule 1 by F alpha noise and the random walk case. So in 2012, there was a paper in which the directed Abelian sandpile was used on some 2x strips. So this is some ladder type configuration, where the possible configurations of grains is we have 4 possible configurations, but out of these 4 possible configurations, there was only 3 possible configurations was allowed after some transient time, and the total possible configurations it means that we will get some recurrent configurations to the power n. And we can map the configuration at a steady state into some random walk condition. So it means that the total possible configurations, configuration at a steady state, they represents we can label it such that that label shows a point in a state space. So, it means that the time series, it shows that it follows a random the mass fluctuation mass fluctuations follows the random walk at some ring of size 3 to the power n, and this is the power spectra for the mass fluctuations. It shows that it follows 1 by F alpha behavior. So in our case, I'm trying the directed Abelian sandpile on cylinder, where we have a long cylinder, and in this case we have so it is directed one. So all the flow of the grains will be in only 3 directions, in this direction and upward and lower direction. This is the relaxation rule for the sandpile on cylinder. So in a long narrow cylinder, at a particular point, number of grains can be 0, 1, 2 at steady states. So on the basis of that, we propose some rules for the recurrent states. There are three rules. It means that in a particular steady state configurations, there will not be 2 nearest neighbor site which have no grains on their state, and this particular configuration is also not allowed. And each time in a particular ring, the total number of grains must have greater than or equal to the size of that ring. So it means that, for example, we have for 3 cross LX types of cylinder, we will have some 27 states. Out of these states, after recurrent after transient time, these states are not allowed, and only these states are allowed. So here there is some group operator, where if we are putting 3 grains at a particular point, it will show it will topple. And then if there is some configuration C prime, so we are putting this operator xy, then we will get some another steady states. And all the times when we are putting this operator at a particular ring, the mass of the next ring will be increased by +1. And if you apply this operator on each point corresponding to the y, we will get the same identical configuration. So in general, we can write this operator as this form. So as if you observe the mass fluctuation at its steady state, it shows that it follows the 1 by f alpha behavior with 1 by f alpha behavior. But once we try to map it in the random walk, means how the steady state configurations are changing after operating the operator. So we can map it with each configurations. We can map it with using this expression, and to reach to each recurrent configuration, we can attach unique label xt, and this xt in the state space. So this is a time series for the xt, means what is if we have a steady state configurations, then how the corresponding state space points are changing. And once we looked at the Fourier transformation of this types of signal, we are getting 1 by f alpha behavior with the alpha is equal to 2. So, on the basis of this, till now, we can conclude that on a narrow cylinder with Ly is greater than, provide a model to study the behavior system having more, because in Ly is equal with Ly on the case of ladder, the allowed states and the total possible configurations were very less. But as we used to increase the circumference of the cylinder, we will get more complex and more allowed states. So the proposed rules gives a clear picture for the allowed and forbidden recurrent configurations, and we are trying to map the mass fluctuations at a steady state to the of the cylinder to Levy flight or in a one-dimensional lattice. So this is ongoing work, and this I would like to acknowledge my supervisor.
Thank you, Abdul, for your interesting talk. We have time for 2 questions.
You had a toppling rule in the previous slide. Can you just bring it? A cubed equal to something, that one.
This one.
No, the a cubed equal to a. So can you explain this one?
This one.
The top one.
So in the case of directed sandpile, so there is the flow in only these 3 directions. So
so then it
means that
the equation is wrong. No, it will be x plus 1, y plus 1. No, or
so
x y plus 1.
X plus 1 means the forward, the next one.
Is the forward one.
And then
okay. All right. Thank you. I did.
Since there are no more questions, we can move to the next speaker. Thank you, Abdul.